use this one for this time. I use it for English and
I do have to say, you guys remember your trig very, very well. I was impressed by our work yesterday. Let's be impressed by the work today. 1 plus tangent squared is secant squared. What is sine squared plus cosine squared? It is 1, right? Is that beautiful? So we want to simplify number 32. We got a thought how I might simplify number 32?
Replace 1 minus secant.
Yes. Replace 1 minus secant squared with negative tangent squared. And I get negative 1. Remember our other Pythagorean identity, 1 plus cotangent squared is equal to cosecant squared. What would you do here to simplify this expression?
Negative sine.
I see a cosecant squared. Go ahead, Brody. Right, so I have a cosecant squared. If I simply subtract 1 from both sides, everybody see that I get a cotangent squared? So I have tangent squared of x times cotangent squared of x. What is the relationship between tangent and cotangent? They're inverse of each other. And what happens if we multiply two reciprocals? You get 1. Go ahead, do 34, 35, and 36. Try them out. You see the Pythagorean identities? Work through them, see what you get. Go ahead, take a couple minutes.
See cross country?
No, he doesn't do any sports.
He just says
he was a D1 basketball prospect. Before he retired. What does he do now? Doesn't do anything, he just spikes around top.
Would you tell me?
Like this.
I got cotangent squared, tangent of x, and tangent squared of x. We all good with that? Okay. You guys are fine, if you know these pieces, to continue on with calculus. Most importantly, know how to find your terminal points. We covered that. Interpret between degrees and radians. Of these values, again, the sine of 0 is 0, the cosine of 0 is 1. Make a general sketch. And your Pythagorean identities, make sure that you know those. The only one we didn't really practice was the sine of the double angle. What you have with you is you can keep these for notes. I do have people that reach out to me from college. They do like this unit circle piece. They also like, not this sheet as much, but they really do like this sheet right here. This is something that they do use a lot. Okay? All right. You're ready for your next unit. talk to the person next to you. What is the lowest percent grade? What is the lowest percent grade that you would be okay with for the semester in this class? What is the lowest percent grade you'd be okay with in this semester?
93.
I mean, that'd be fine. But
Well,
it's not
regarding that,
it's not golf, so I won't move on.
No,
Maybe
the
more
girls'
than
game, yeah.
regarding the math right now, probably anything other than that.
I didn't see
Anything
I
that's
think
pretty
it was
that
like,
day.
why don't you guys stay for the boys' game?
Two as a plus.
It was-
Say
It was freezing that our I didn't get into soccer.
I
I
went
can't
some of the
stand
time.
soccer.
Like
I
that.
was watching the boys once.
It's like watching hockey at
Yeah, the
grass.
boys
It's
once.
up to every athlete.
It's not.
No, not at all.
You know, this
It's not.
package
Such
is
a bigger-
unfixed from a.
There's so
Holy
much
moly.
less going on.
Those are the ones
Yeah.
that, like, you need
Like, I feel like if soccer was more competitive, it'd be, yeah, I agree.
Give your
It's like, even like,
It's just
I would
like
just
such a
kick it
better
in,
feeling.
even if it's soccer season.
Even if they're so fast.
I know you like offense more than.
We can finish something, they kick it out.
Yeah, like a defensive strategy is to just kick it out of bounds. Yeah, that's all
Yeah,
we
it's
do.
why is there like unit 3 and then
Holy
unit
moly,
7?
this thing's a freaking packet, yo. Dude, you just, some kids don't move like that. Have you seen that video?
No, I haven't.
I had a
We
headache.
just-
Yeah,
It's not like every time we on you watch.
Hey, Gens, just look up the video clip.
Just
We
search
need to
freaking
watch
packet,
it.
yo.
Alright.
We need to watch
We'll,
it.
we'll watch it right as soon as we're done with the lesson.
No.
How long is
That's
Um,
a packet.
so I continue to hand these out to you, just again let you know, but the book that you have is actually a maroon book. If you ever want the maroon calculus book, I can get one to you. You don't want it? I stopped handing it out because people would say that it sat in the trunk of their car and they never used it. And so it used to be that I assigned all the assignments from the book, and the kids would just take pictures of the book, and that's how they got their assignments. But in order to check their answers, they would come in, they grab the calculus Bible every day, and they would check through to check their work to see how they did. But I noticed that as I assigned worksheets with answer keys, that kids were more likely to not only complete the assignment, but they were also more likely to complete or check their answers. Do you agree? So there came a 2-year period by which I made every single calculus assignment and every single college algebra, college trig assignment, and every single math for college assignment into a worksheet. And it's really just for your convenience. You know what I'm saying? So we don't really carry around the books anymore, do we? So what is the lowest grade you'd be willing to accept for the semester? You're my daughter right now, my youngest, Tenley. She is not the highest performing student on the standardized tests. Of the 3 of the kids that I have, she would be the lowest performing. Still performing well. We went yesterday to conferences, and she's doing very well in her classes. However, if it came time to take like an ACT test or an AP exam, she wouldn't be as likely to score as high as maybe the other 2 might. Okay, and that's just it. Back when she was in 6th grade, she hated school, hated every bit of it. She wasn't identified in advanced track, and she was bored out of her mind through her classes. And yesterday, she had a grade in one class of a 95%, and she was kind of worried that that might drop too low. And I had to kind of have the talk with her. I said, honey, so what would you rather have? Would you rather have a class where you're having fun and enjoying it and learning and getting an 88%? Or do you want back to 6th grade where everything was easy and you got 100%, but the assignment took you 5 minutes and you hated class? You get my point? So at the end of the day, I want you to know that nobody here is going to get lower than a B. I can promise you that. You're all very good students. You're very capable. I can't promise that all of you are going to get A's. I can't promise that. But at the end of the day, the difference between an A and a B, it's really between your 2 ears. Nobody else cares. Really, nobody else cares. Okay? Andrew's going to Bethel. Give him a round of applause, everybody. Yeah. And your calculus grade will not be reported to Riverland until after you actually graduate. Did you know that? Your Riverland grade for calculus will not be reported until after you graduate. You are going to get semester graded through this school, but that'll be it. And even when people look at scholarships and stuff like that, nobody's going to see your calculus grade. Nobody. You made it. Congratulations. So just show up and enjoy learning. We good? As I said before, the gloves are off. This unit can go well, but this unit can be tough. I cannot lie. So there is a fair amount of stuff within your packet. You wonder, why is it that we have these additional things? It's because we're going to teach you how to take derivatives of not just one thing or two things or three things, but of everything. Okay? So you are going to have the opportunity to get your driver's license after this test. Now, I'll tell you right now, the very difficult part here, in 7.2, you learn the derivative of e to the x. I already told you once before, anybody want to know the derivative of e to the x?
Yeah, sure.
It's e to the x. That's lesson 7.2. So that's why we could just kind of throw it on. And now I'll tell you another one. The derivative of natural log of x is 1 over x. That's all it is. Pretty simple. And then in 7.5, you learn some other derivatives that are a little bit more challenging. But let's start right now with learning some application that we are going to do and build on throughout the entire year. Make sure you have your calculator ready to go. And away we go. I think it's only Paradise not here today. Is that accurate? We want to give a shout out to Paradise?
Are we gonna have a keyword for her?
Hi. Should we?
Yes.
Okay, what's the keyword for Paradise?
Calculator.
Python.
Python.
No.
Red Python is the keyword.
Paradise, the keyword is
Red Python.
apple crisp. There we go. I'm making an apple crisp this weekend. Keyword is apple crisp. If you send me an email with the word apple crisp, I will give you one of, well, I'll just bring some chocolate for you because I know you love that. So there we go. Ready? Here we go. This is our work. Okay. As I said, gloves are off. You're going to have a number of days where you're going to have time to practice in class, but we are on our way. So, suppose that we have S is equal to f of t. We have what we call a position function. And a position function tells us where, picture a particle moving along an x and y axis. Okay, so picture we have not an x and y axis, but just the x axis. You have a particle that starts at one location and it moves back and forth. You're kind of wondering, where is it at? Like right now, is it at a spot of 1? We're going to say that S equals is a position function. We have another function that we use, and that's called a velocity function. A velocity not only tells us the speed, but it also tells us the direction. For example, when I drive home, I drive 75 miles an hour to Owatonna. That doesn't mean when I drive from Owatonna down to Albert Lea that I drive negative 75 miles an hour. You have my point? Mm-hmm. But in velocity, you do have negative velocity. So I would have to decide which one was positive and which one was negative. So that's the difference between velocity and speed. One's positive, one's negative. The velocity function is a rate of change. How do we determine the rate of change of position? Simple. We take the derivative. So the derivative of the velocity function, or derivative of the position function, produces the velocity function. Do you know how to take derivatives now? Yeah, good. Particle is at rest when v of t is equal to 0. So when the velocity is 0, we know that the particle is at rest. We say that the particle is moving in the positive direction or to the right when v of t is greater than 0. And we say that the particle is moving in the negative direction or to the left when the velocity function is less than 0. So velocity, or the derivative, tells us a lot about the nature of the function. So I'm going to do a couple things here. Very important in this first lesson. This is a 2-day lesson, by the way. We'll do this today, and we'll do it Monday, and give you some time to work on Monday. And then Tuesday and Wednesday. Wednesday, you will not have an assignment. We do something in class to kind of show you, but you will go home with a couple assignments to be ready for. But you'll be able to get some of it done this weekend. So I'm going to graph this guy right here. Talk to the person next to you. What does a cubic function look like? Go ahead. What does a cubic function look like?
I don't know.
Okay, so the cubic function is going to look something like that, right? something like that. And as I draw this function, okay, I have if I factor out the t, I get t times t squared minus 12. I know then that the function crosses the x-axis at 0, and it crosses at plus or minus the square root of 12. Everybody agreed? So the square root of 12 is about 3.5. So I'm going to go back to 3.5 here, here, and here. And we go ahead and draw the position function. Very important that you understand and lean into this piece. I'm going to point to a spot and tell me, right here, is my position positive or negative?
Positive because it's going up. I don't know.
Position, no, it's okay. The position is negative because I am below the x-axis. Sam, is my velocity positive or negative here?
Positive.
Positive because the derivative is positive. Good. Is my position positive or negative here?
Positive.
Is the velocity positive or negative?
Negative.
Negative. Position positive or negative?
Negative.
Velocity?
Negative.
Negative. Position positive or negative?
Negative.
Negative. Velocity?
Positive.
Positive. We all good with that?
Yep.
That's when we're looking at the original function. We are also going to graph the derivative. Find the velocity at time t. This will be the first question that you have on your test after you list all the derivatives of all the different functions that we have. To find the velocity, we simply just take the derivative of this. What is the derivative of t cubed minus 12t?
2t.
Squared.
TQ. Is that
Wait, what?
2t. Oh.
3t squared.
3t squared?
Oh, wow.
I took the derivative.
We all good with that? Okay. Now what I'm going to do is I'm going to draw a picture of the velocity function. Remember, if this is a cubic, then the derivative is going to be a quadratic, a parabola, right? So we know it goes down in 1 degree. We've already talked about that all last unit. We're going to use all the last unit on this unit. I could just factor out a 3 in this situation, get t squared minus 4. So I know this is a parabola that crosses through. Negative 4 and is, well actually negative 12, but it crosses through positive 2 and negative 2 for the x-axis. I'm not so worried about the y-intercept, but I am worried about the x-intercept.
Wait, so you found that out the t squared minus 4?
Yep. So t squared minus 4 is going to have solutions of plus or minus 2. So I know it crosses through positive 2 and negative 2 there.
How do you take a degree out of t to the third?
I don't know.
I took a 3 out of this right here.
Oh, that's okay.
Does it have to go down to -6 or?
No, it doesn't. We don't really care where it goes on the y-axis.
So then you're square rooting the 4, like it would be like.
So 3 times t minus 2 and t plus 2. So we know that it crosses through positive 2 and negative 2. Okay. So this is my velocity function. I want you to notice that in the instructions it does say the particle moves according to law of motion of s is equal to f of t for t greater than or equal to 0. That means that time is only positive. We're not talking about negative time. And so we won't talk about negative time really at all. So let's look at this piece right here. Okay. You tell me, is the velocity positive or negative?
Positive.
The velocity.
Oh.
Is the velocity positive or negative? Negative. This is the velocity function. It sits below the x-axis. Do you see that?
Oh, it's like the opposite.
This is it. It's just absolutely critical that we all put this piece together, okay? So watch, okay? Because everybody has to get this. I'm going to go to this spot over to a t-value of 1 right here. Everybody agree that the velocity is negative because it sits below the x-axis?
Yeah.
Look at where that corresponds up here. If I go to a t-value of 1, the position function, see how that has a negative slope? So therefore, the velocity function sits below the x-axis. As I move over here, is the velocity positive or negative right there?
Positive.
The velocity is positive or negative. As you go over to 3 on this one, notice that the slope is positive. See what I'm saying? Okay, so is the function, or is the particle traveling to the right or the left at this time?
You're right.
To the left. Is the velocity positive or negative?
Positive.
Negative.
Negative.
This is the velocity function. It is negative, so the particle is traveling to the left. Here, the velocity is positive, so the particle is traveling to the right. Left when it's below the x-axis, right when it's above the x-axis.
So the velocity on that bottom one is negative?
The velocity right here, this means that the velocity is negative. Right here means the velocity is positive. If I can for a second, I think that this might help you. Notice this green portion here, that's when the velocity is negative, agreed? That corresponds with this section of the graph. You guys all told me that the velocity was negative there, right? That corresponds with that section right there. As I move past it, this section of the graph right there, that blue section, corresponds to this section right there. That's where the slope is positive, so this is above the x-axis. Now you know why in the last unit we talked about graphs and which derivative kind of matches up with what, okay?
Yes.
Yes.
So like the parabola there is kind of like a second, it's kind of like a second graph to the velocity is kind of like going off the first one.
Without a doubt. Yep. Yes.
So that means the left side of the parabola, like the top portion, is that?
So this portion right here is going to correspond. So this is the velocity is positive, right? So that would be where the slope is positive here. So that green portion there is that green portion there. See it?
I got another question.
Yes, sir.
So do you ever have it where the first problem is the parabola? Like
Sure, you could, yeah.
But then, so the bottom would be positive?
Sure. Yep, that could
That
be.
bottom spot would be positive if it is the first one?
It's possible to have a situation like that, but it won't always be like that. Okay? We'll come back to it, but let's do something that's easy right now. Okay? So it says, what is the velocity after 3 seconds? So it says that the velocity is equal to this guy right here. So all we have to do is plug in 3. V of 3 is equal to 3 times 3 squared minus 12. 3 squared is 9. 3 times 9 is 27. And 27 minus 12 is 15. Notice how our velocity is positive, right? So after 3 seconds, our velocity was positive, as we thought. When is the particle at rest? Well, that's when 3t squared minus 12, that velocity is equal to 0. We can already see from our function here when the velocity is equal to 0. If we just factor out a 3, we get t squared minus 4. And what were our 2 solutions to that? 2 and negative 2. We don't use negative 2 because we're not talking about negative time. Okay? So just t equals 2. When is the particle moving in the positive direction? Well, that's when v of t is greater than 0. When is the velocity positive? When is the velocity function above the x-axis?
Before negative 2?
Before negative 2 and
After positive?
after positive 2. We are only concerned about the positive. So from 2 to infinity is when it's moving in the positive direction.
You don't include them? Because it's at 0.
Yeah. I won't ever mark you off for that if you decide to put a bracket. AP has a different way of dealing with that situation, but we won't, okay? AP actually always leaves it at that. When there are times where you should use a bracket, but I won't count you wrong ever. Okay, so we all can agree as we look back at this that you know how to take the derivative, you know how to plug in 3, you know how to set it equal to 0, and you know how to look for where it's positive. We all agree? So then let's put it all together right now. It says, find the total distance that the particle has traveled during the first 8 seconds, and also diagram and illustrate the motion of the particle. Okay? And so what I'm going to do here is I'm actually going to draw a small number line, and I'm actually going to do F along with the previous one together. Okay? And I'm going to make a little chart here, and the chart is going to be where the particle starts, where it changes direction, and where it ends. And so we are going to have our time that happens, and we're going to have our position when that happens. And we are always going to start at time is equal to 0. Okay? It changes direction when the velocity changes from positive to negative or from negative to positive. Does the velocity change from negative to positive or positive to negative ever? At what value? At 2. When are we ending the motion of the particle? At 8. So I've gathered my important times, where it starts, where it ends, and where it changes direction. Now I have to figure out where it's located at that time. If I want to figure out where it's located, I don't plug it back into the velocity function. I plug it back into the position function. So if we plug 0 into t cubed minus 12t, what do we get? 0. That means the particle starts at 0. Then we go ahead and plug in 2. 2 cubed is 8, and 8 minus 24 is? So it goes over to negative 16. And then I plug in 8. 8 cubed is?
512.
512, and 512 minus 96 is 416.
I got it just now.
So if you needed your calculator during that time, you sure could use it. That's enough information for us to be able to plot this. So earlier when I was asking about the positive and negative, some people got confused. I think that you'll understand this quite well. I start at 0, I go back to 16, and I go over to 416. Yep.
Could you, so are you able to show like what the 2 to negative 16 is doing on the graph?
Yeah.
Like what is it on the graph? Where is that happening? Yeah.
So on the graph, that would be its location right here. And I think when I show this, I think you're going to understand better what happens. Okay? What this means is the particle starts at a location of 0. From 0, where does it go?
To 0.
To negative 16. Was that in the direction of the left or the right? Left. Notice that matches with this piece right here, doesn't it? It starts by heading off to the left. Then Gilly right here, it changes direction and it heads on off to the right. That's the motion of the particle. Starts at 0, heads back to 16, turns around, and heads off to 416. I need to find the total distance that this has traveled. Well, how far did it travel to get from 0 to negative 16?
16.
How far did it travel to get from negative 16 back to 0? Another 16. And how far did it travel to get from 0 to 416? Another 416. So, in this situation, it traveled a total of 448 feet. Please take out your homework. I want to see if we can try to do the first one.
Can't wait to almost get back and then look back and
I'm gonna put the answers to A, B, C, and D on the board. Go ahead and see if you can do part A, B, C, and D. Okay? Part A, B, C, and D.
Boom. Already got the velocity.
Sorry.
Still, bro.
Oh, 2, T. So V equals D 2 times T. V3. That's okay. 3, 2.
Motion.
So it's a line. You have to figure out where this is the x-axis. Is that what it is?
Again, so it'd be negative.
What did I do wrong? For B.
Oh, yeah, sorry.
B, you plug in to the original equation. No. Oh, to the derivative.
I'm just gonna put it.
So 6 minus 10 is
6, 7, 8, 9,
Wait,
10.
is it always the same? Oh, wait, it's always the same in words. It's always the same as C.
Checks out. I'm hearing that you're putting it down.
Are we all on the same page with this?
Yeah.
We're all okay? Okay, then if the bell goes, I'm gonna beg that I could keep you just a little bit past, because you're right on the point of we gotta solidify one last piece here. I really wanna do E and F. So I wanna help you set that up, because this is gonna help us carry, in fact, I don't care if you don't do any of your homework this weekend, because on Monday, we have to start with this right again, okay? But then you gotta do it Monday night,
I know.
trust me. But so we're gonna do E and F. E is the total distance, F is the motion of the particle. Okay, so what do I need to consider when I consider the motion of the particle? I need to consider where I,
Start,
and where I,
change,
and where I,
and
where do I start? Start at 0, where do I change?
5,
I change at 5, and where do I end?
8.
I end at 8. So that's great, those are the times. How is it that I figure out the location? Plug it into the original, the t squared minus 10t plus 12. Please go ahead and plug those three values into t squared minus 10t plus 12 and see what you get for those three spots there.
Wait, why do we have
So
an
I
eight?
got a little, but how do you
What
do
is it
this
in the eight?
again?
So it changes direction where it changes from negative to positive, and that is at 5.
It's because the
And
total
then
distance of the
And
particle.
it says
Find the
over the
total
course
distance
of
of
the
the
first
particle
8
after
seconds,
equals
so that's
seconds.
the end.
Alright.
5 to
Doesn't
3.
say exactly. Oh my gosh, that was the little candy, I'm sorry. It's not.
Attention Tiger Band students, please report to the band room for 8th hour. Again, Tiger Band students to the band room for 8th hour.
Again, please give me just a little bit through the bell. Did you guys come up with these three values? We have 12, what do we have for 5? Negative 13, and what do we have for 8? Negative 4. So, what I like to do is just plot 0, what I put down a negative 4, I put down a negative 13, I put down a 12. And sometimes I like to put the time underneath it so people can understand. The 12 is at time equals 0. The negative 13 is at time is equal to 5. And the negative 4 is at time is equal to 8. So if I follow in accordance with time, I start at 0, I go back to 5, and I come back to that negative 4 spot. And that's the motion of my particle.
So why did you put a 0 on?
Just so I can break up my positive and negative numbers, if you know what I'm saying. It kind of helped me because watch this. Sometimes as you add them up, how far did I go to get from 12 to 0? I went 12 units. How far to get from 0 to negative 13? Another 13 units and another 9 back. So I can see that this is 34 units that it travels.
What comes from the change?
If you want to, so within your assignment, you could do problems 1, 2, 3, and 4, not 5 and 6. But I promise right away on Monday, we're going to start with a practice problem very similar to this again to see where you're at.
As long as it's not okay.
Good job today, guys. Good job.